Now, dear students, next topic, that is angular velocity and its relation with linear velocity. So, previously we studied about linear motion, or we can say translational motion. So, in that we discussed this thing. If you want to explain the motion in detail, then you have to think about some physical quantities associated with that motion. So we discussed about linear velocity, linear acceleration, then force, linear momentum, etc. In the same manner, if we want to explain the rotational motion in detail, then we have to think about some physical quantities associated with rotational motion, like angular displacement, angular velocity, then angular acceleration, then angular momentum, torque, like that. Okay. So first we have to think about angular velocity. Okay. Now we know this thing, in rotational motion, each and every constituent particle of the rigid body execute circular motion, and centers of their circular path lies on an imaginary line, which we say that is the rotational axis, with respect to which the entire body is executing rotational motion, and each and every particle is executing circular motion in the plane which are perpendicular to the rotational axis. As shown in this particular figure, suppose we consider here any point P of this particular rigid body, which one is rotating with respect to this Z axis. So here particle P is executing circular motion, and center of its circular path C that lies on this rotational axis. Here R, that is its radius of a circular path, or in other words we can say that is the perpendicular distance of that point P with respect to this rotational axis. Now suppose in time interval delta t, particle P reaches at position P dash, and here suppose the angle subtended at the center, this angle P, C, P dash, that is delta theta. Okay. So this delta theta, that is called angular displacement of the particle, and this one is the rigid body. Relative positions of the constituent particles never changes. Therefore, whatever is the angular displacement of any particle itself is the angular displacement of entire body. Now here we can say this thing, in time interval delta t, the angular displacement, that is delta theta. Okay. So average angular velocity or average angular speed, that we can write omega, that is equal to angular displacement upon time interval. So that is delta theta by delta t, because angular displacement that we discussed, that is delta theta, and that is in time interval delta t. Here angle is measured in radian and time, that is in second. So here unit that you can write radian per second. Now here suppose we take limit delta t tends to 0. Then in that particular case we will get the instantaneous angular speed, and that is omega equal to limit delta t tends to 0 delta theta by delta t, and we can write this one as omega equal to d theta by dt. Right? Here you can see the analogy with linear motion also. Right? The differentiation of a position with respect to time t dr by dt that give you linear speed. Here the differentiation of angular displacement with respect to time t that give you angular speed. Okay. Now here unit that will be radian per second or rotation per second. Clear? And this one is the angular speed of entire body that we already discussed. Now when angular speed is represented with direction, or we can say if a proper direction is associated with angular speed, then it is called angular velocity. Okay. Now here the direction of angular velocity that can be fixed with the help of right hand screw rule. Now how we have to use this particular right hand screw to fix the direction? Okay. So we have to place right hand screw parallel to the rotational axis. Okay. So suppose this one is our rotational axis and parallel to it this one is the right handed screw that is placed. Now suppose your body that is rotating like this, then you have to rotate this right handed screw in the direction of the rotation of body. So you have to rotate right handed screw in same direction like this. And if you rotate this right handed screw in this manner, or we can say the direction in the rotation of the rigid body, then the direction in which right handed screw transverse, that is the direction of angular velocity. Here simply you can represent this one with the help of right hand thumb rule also. If this one is your rotational axis and your body that is rotating like this, okay, so encircle your fingers of right hand in the direction of the rotation. Your body is rotating like this, so you encircle the fingers in the direction of rotation, then thumb automatically will point you the direction of angular velocity. If your body is rotating in this manner, encircle your fingers like this, then your angular velocity is in downward direction, right? And if this one is rotating in this manner, encircle your finger, your angular velocity that is in upward direction. So here remember one thing, angular velocity that is always along the rotational axis, either in upward direction or in downward direction, but it is always along the rotational axis. Clear to all of you?